Morning. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps webinar, Databases on Kubernetes, Enabling Innovative Apps from the Data Center to the Edge, brought to you by Red Hat and Crunchy Data. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it again. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars, and it will be available to you as well. We're taking questions from the audience throughout the presentation. To do so, use your webinar interface to submit questions into the Q&A section, and we will try to get to as many as possible at the end. Finally, stick around until the end because we are doing a drawing for four $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Jonathan Katz, Vice President of Platform Engineering, Crunchy Data, and Jehlum Pandit, Product Marketing Manager at Red Hat. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Okay, thank you, Julio. Thank you for the introduction. So to briefly recap, I'm Jonathan Katz. I'm the VP of Platform Engineering, Crunchy Data. I'm very excited to be presenting on this topic today with Jehlum Pandit, who's in product marketing at Red Hat. And not only are we going to talk about running databases on Kubernetes, we're going to look at really how far we can push this concept, and we're going to take it right to the edge, literally. We're going to learn how to store data at the edge on OpenShift using all open source technology, and really allow us to bring a whole new class of application and make it very accessible through edge computing. So just some brief introductions, a little bit about myself. Before joining Crunchy Data, I was previously involved in engineering leadership at a bunch of different startups, pretty much coming from the application developer background. I was always the accidental operations person. Somehow it would fall into me, probably because I would tout Postgres so much and my love of that project. And sure enough, that actually got me involved in, as an open source contributor. I've been a longtime contributor to Postgres, primarily on the advocacy and outreach side and governance side. Currently a core team member, and I've been involved in things from conference organizing to NPO governance to social media outreach. And with that, I turn it over to Jehlum to introduce herself and start talking a bit about what is this whole edge computing thing.
Yes, thank you, Jonathan. So I'm Jehlum, and I'm in product marketing at Red Hat. And I joined Red Hat last summer in 2020 as an intern, and I was focusing on workloads in OpenShift, which is where I'm focusing now when I joined full time. And I have a special interest in databases and data analytics workloads, as well as Kubernetes operators in Helm. So let's dive right in. So this is what we're going to cover today. We will start by talking a bit about what edge computing is, why are businesses adopting it, and then understanding how databases fit into this edgy picture. We can then go over what a desired architecture might look like for use cases, and the challenges that one might face implementing them, and how Red Hat and Crunchy Data can help you in this. So let's understand what edge computing is and how databases lend themselves to it and what use cases these things can jointly drive. Edge computing essentially extends processing and distributes it. It places processing power closer to the users and to the data sources, which eventually helps organizations support latency sensitive applications and to scale their architecture. Organizations no longer have to be restricted by geographies, remote locations, or by storage constraints. So, why are businesses doing edge? Many industries are exploring the benefits of edge computing as it helps create differentiation. It allows organizations to react faster, connect everything, regardless of where it is, and deliver better experiences and business outcomes. Some key things that organizations are able to do with the help of edge computing is that they are able to use data derived from sensors, videos, devices, or any other edge devices to make fast data driven decisions. Edge also allows them to deploy latency sensitive applications with the experience that users expect, regardless of where they are. And data can be kept within geographical boundaries to meet regulatory requirements on data storage and processing. So overall, edge computing is really helping businesses gather and process data faster to identify new opportunities, offer better products, offer better services, as well as create new revenue streams and reduce costs. Now, what exactly are businesses doing at Edge? The first thing to note is that Edge is not really specific to a particular industry, and it can be seen across enterprise, public sector, telco markets, any and all industries. But the benefits that these industries derive from edge computing are pretty much similar. Faster processing, better application experiences, the use of data and analytics to make better decisions, like building better products, cost control, etc. One crucial thing that you might recognize across all of the use cases we have listed out here is that they're making use of a lot of data driven insights. All these use cases and many more are utilizing data at the edge, and they are powered by deploying workloads such as databases at the edge. So, what value are the databases at the edge providing to companies, and how do they lend themselves to the many use cases that we just saw? So, Edge essentially allows businesses to put workloads where it makes sense to them, be it closer to the applications, closer to the end users, or even at remote locations such as oil rigs, trains, ships, cruises, even in space. Databases are incredibly powerful when deployed at Edge. When deployed at Edge, databases can store data locally closer to the applications, which helps save time, analyze things faster, and make faster decisions, providing a better overall experience. When the data is stored at the edge site, it allows for use cases on airlines, satellites, military applications, etc., to ensure continuous and offline connectivity. In case the edge site loses connection to the main central locations, or in case it loses internet connectivity, data can be stored offline at the edge until the edge site gets the connectivity back and can upload all of the data gathered to the central database, basically ensuring that no data is lost even in case of disaster. Keeping the data at the edge site also allows organizations to meet regulations and keep the data locally within geographical locations. This allows them to meet regulatory requirements and be compliant with data sovereignty rules. So, as we are seeing organizations ramp up their focus on edge computing and data driven insights and deploy databases at the edge, let's talk a bit more about the data management capabilities that you would need at the edge. What would a data pipeline from edge to on prem or the cloud look like? What tools would you need? The first step would be to ingest and aggregate the data that is being generated at the edge. This could come from various sources, for example, sensors, smart devices, medical devices, military devices, anything, and so on. Next, this data can be stored in an operational database deployed at the edge that stores data closer to the applications, and this could be a SQL database such as Postgres. Another key component of this data pipeline is the central database. That could be anywhere. It could be on-prem or in the public cloud or in the private cloud, anywhere. And it stores the data collected from the edge site or from other systems or applications and consolidates all of it in a single location. And the final important components are the data transformation, the data transfer, and analytics tools that will eventually help prepare, process, and transform the data and make it ready for use cases such as data analytics, AI/ML, or any other things. And the tools that can be used are Presto, Apache Kafka, etc. So how do we piece all of these together? How do we piece all of these components that we just spoke about into what? How do we understand what goes at the edge and what goes at the more central site or in the cloud or on-prem? Let's talk about what an architecture might look like for deploying databases at the edge. So the use cases that we are seeing and the applications that are being built lend themselves very well for containerization. These apps ideally require positioning a small workload at the edge, and adopting containers for these applications delivers a faster time to market, improved application quality, and the agility to respond to changes in market segments. Containers can power innovation at the edge because they are portable. Containerized applications can run across core data centers, public cloud, or edge infrastructure, as we just discussed. providing a very flexible approach that lets organizations evolve their application strategy to meet business needs. Containerized applications are also very lightweight, so they can start more quickly and are lightweight enough to meet the small hardware requirements, which is in fact perfect for edge sites because they just have really limited physical footprints or storage capacities or even power and cooling resources. Finally, to make edge computing successful, applications need consistent lifecycle management across a wide variety of systems and at large scale containerization. It supports a consistent application development and deployment experience. So let's take a look at what a conceptual architecture for containerized databases at the edge might look like. We start at the edge by ingesting data at the edge site and deploying a database to aggregate all of this data at the edge site, closer to the users or the application or whatever benefits that you are looking to get. Some key things to watch out for this database that is being deployed at the edge is that it ideally should have a very fast response time. It should be able to handle a very large amount of data and ideally should be available offline. All of these will help in case of offline apps or if the edge site loses connectivity or is in a really remote place. It should also be highly available and should have comprehensive disaster recovery strategies along with being secure, of course. The data from this edge database can then be transferred using data transfer tools such as Apache Kafka, etc. And these transfer tools can serve as a connection between the edge site and the central site. On the on-prem side or in the cloud, we can have a data ingestion tool again to aggregate the data coming from the edge site and from other sources. And eventually it can be stored in a centralized database, which could be a Postgres database, and it could be the single source of truth for all of the data that you're generating. The next step is to prepare, process, and transform this data, perform analytics on it, or use it for AI/ML or some other use cases. For a cloud-native architecture that spans across the edge site and the central site, a containers and Kubernetes-powered hybrid cloud platform is required to run the entire data pipeline in a very consistent way for all of these stages that we just saw in the data lifecycle. But as we try bringing all of these pieces together, the database, the edge site, the containers and Kubernetes, there still might be some things left to look out for. Some considerations for edge can be how can you support a scaled out architecture with existing teams, existing IT and developer teams, especially because edge sites tend to be in places where there might not be a lot of experts or any experts placed at all. Again, as we move to the edge, there is a lot of variability in both hardware and software, as well as how much space is available and how much connectivity is available. So, how do you manage this variability? How do you manage the architecture that can have tens to thousands of nodes or clusters? These are all things that you should consider when thinking about edge computing. Again,
Evan.
on the sorry, yes.
Hi, Joe. Please continue.
Yeah. Oh, okay. Yeah. So on the data workload side, there are also some potential concerns when it comes to deploying data workloads on containers and Kubernetes. Data loss, failures, and downtime could be a concern. So is the operational complexity and the performance trade-off that could be included. And there's definitely a huge concern about lack of skills or lack of ISV support and documentation. So these are some things that you should keep in mind when selecting which database partner to go for.
Yeah, and a lot of those, and on the managing data complexity, that applies to any environment. It doesn't matter if it's on OpenShift or bare metal or virtual machines. These are all challenges you see in them. But this is where there's a lot that we can leverage in OpenShift and Kubernetes and containerized platforms that can help make the complexities a lot smaller in terms of managing the data. I think with that, let's talk a little bit about what Crunchy Data and Red Hat have been working on through the years around this. And going to the next slide. First, the question is why deploy databases and data analytical workloads on Red Hat OpenShift? And this was a question that when I first joined Crunchy Data, several years ago, the big question was, why even run a database in a container? The question today has changed. It's more like, why don't you run a database in a container? And there's a lot of advantages for that. First, the idea of automated operations, that you can declaratively declare a database. You can just say, hey, I want to run Postgres. I know I need 2 cores. I know I need 4 gigs of RAM. I want high availability. I want my backup stored, in an object storage system somewhere. And boom, like all of that, gets created. That takes a huge operational burden off of application developers, and something, as I mentioned up front, I'm very sympathetic to. And the fact that it's also both consistent and portable, that my manifest for deploying a Postgres database works no matter where OpenShift is deployed. It could be on-prem, it could be in the cloud, it could be a hybrid solution. No matter what, like the same manifest is going to work everywhere. And that's huge, and that's something that I even saw when I first started working at Crunchy Data. Is that wow, with OpenShift, I basically have made my data workloads platform agnostic. There's just a unified API for doing this. And last but not least, having the correct partnerships and integrations, with ISVs can certainly help you, optimize your databases for production workloads, and help tailor them to what you're doing. And again, Crunchy Data and Red Hat have been working together through years on this. I mean, we started working with Red Hat when they were called cartridges, not containers yet. So we've been on this journey together, and we've through the years that we've developed the solution that I'm about to talk about. We've really worked on bringing the best of open source Postgres to OpenShift, and tailoring that experience to production geared workloads. So with that, click. Let's talk a little bit about the open source solution that we bring, Pigo, the open source Postgres operator for Kubernetes. This is part of the Crunchy Data for Kubernetes offering that we bring. And as mentioned, we've been working on this for many years and have collaborated with Red Hat throughout the years as we've developed this. It's been open source for over 6 years. You can check it out on GitHub right now, github.com/crunchydata/Postgres operator. And the idea was solving the question, what do you need to run open source Postgres in production on OpenShift or Kubernetes or any platform that supports the Kubernetes API. And the idea is there's certain boxes that you need to check. What's my availability? How can I deal with a disaster recovery scenario? Can I monitor my database? Is it secure? Can I check all my compliance checkboxes? And is it easy? And again, this is I keep coming back to, being an application developer, oftentimes like I need a production database, but I need to make it as easy as possible to get up and running. I know I need high availability. I know I need my backup stored somewhere, but I don't necessarily want to have to go through, the many steps to get all of that set up in, for a stateful service like Postgres. I just want to say like, hey, I want all these things and have them declared. The good news, this is what Pigo does. High availability is as easy as saying, hey, I want 2 Postgres replicas. It makes it very, it's very easy to swap out images. Postgres 13.5 is coming out in a couple of weeks. I'm going to want to upgrade and get whatever bug fixes there are, since the 13.4 release. I can just change one line of YAML, and that update gets rolled out. And not only that, it gets rolled out in a non-disruptive way. And that's the key too, because again, coming from my previous background, I know I want my database to stay up. I know that's the linchpin of my application. I don't want to have to worry about managing the uptime myself. This is the power of an operator, is that it can handle all these operations in a self-contained way. So I think we're going to see how this all plays into the edge, because the idea is that we want to make the database management aspects of our edge computing cluster as simple as possible, but still be able to maintain the production quality components that we need. Click. So we talked a little bit about the features of Pigo, but what is the user experience? It's fully declarative. It supports GitOps. It can work with your favorite tools, be it kubectl, Helm, OLM. You can deploy from Operator Hub. And the point is to make it as easy to get started, whether it's running a development workload or a production workload. We make it as easy to upgrade as possible without having to think. You can upgrade components as you need to. They're going to roll out in a non-disruptive way, and it's production ready. We've been developing this in the open source project for 6 years. It's been battle tested for a long time. We've seen the evolution of Kubernetes. We've seen the evolution of OpenShift, and have been ready for a lot of different scenarios. Within the two. And this also lends itself to getting into larger distributed systems like on the edge. Click. So let's look at an architecture for how we can get this done. To do edge computing, you need to tie a lot of things together. In some ways, this is why we're on the edge. As Jehlum said, the principal ideas around this are being able to persistently store my data somewhere, and then be able to stream it in a way where I can bring it to other data storage tools for later analysis. So somewhere you're going to have an edge database, living out, in some cloud. It could be on a smart device, it could be in a satellite, it could be on, on a plane. Whatever it is, you have data that's being collected. The benefit of having it at the edge is it's there. It can serve some immediate purpose. It can help the application do what it needs to get done. But there's also these, wonderful insights that can be available that you're not going to be, you're not going to be doing that on your smartphone. You're not going to be doing that at that edge system. You need to bring it back home. This is where something like Red Hat AMQ Streams helps to bring that data back in. It could be to an intermediate database. It could be into a different data processing area, or it could being back into an analytical database. And once it's in that database, then you can start doing some of the data warehousing, advanced processing, other types of things that you need to do. Where this helps is that by bringing all this data home, you can actually accelerate how you're doing your analysis because all the data from your edge devices are in one place. You save the power on the edge device by not having to do the analysis there. You're able to do it in a centralized warehouse where you're optimizing your architecture, your hardware, your infrastructure for all of the things around that analysis. Click. What's cool about everything that we saw in that architecture is that it's all open source. It's all powered by open source. The Strimsy operator allows you to deploy Kafka on OpenShift in a way that's very convenient and basically makes it very easy to not only deploy Kafka, but be able to set up your environment for transferring data between your edge databases and your analytics database. Debezium creates a standard, it's called like a standard language for being able to speak data between different databases. Now, of course, I want to analyze everything in Postgres. I want to capture everything in Postgres, but Debezium would allow me to transfer that between other databases or take data from, say, some random database out there and bring it into a Postgres database for later analysis. And what's wonderful is that it works very nicely with the Strimsy operator. Last but not least, there's the Pigo, the Postgres operator that is within this architecture. I think the best way to discover how this all works is to demo it. So without further ado, I am going to start demoing. And we're going to see how well a live demo goes. Exciting times. So here's my screen. First, let's make sure we have everything set up. Yep. So we should see a command line terminal. Jehlum, are you able to read what I have on the screen?
Yes, I am.
Perfect. All right. So I've gone ahead and I've already deployed a couple of the components in my namespace. And of course, the first thing I do is I mess up the command. So I've already deployed both operators that we're going to need to use in this demo. One is Pigo, the Postgres operator, and the other is the Strimsy operator, which helps deploy Kafka clusters. I have, of course, pre-scripted this demo, but it will still be live, so we shall see everything that goes. And we're going to deploy two things right now. We're going to deploy our Kafka broker, as well as our edge databases. And you can see that I've deployed 3 of them. Let me just step through the Postgres databases real quick. So if you can see this manifest, here's one of my edge databases. You can see it's actually quite simple to set up. I've done sort of a basic setup only because I'm doing this demo locally and I don't want to tax all the resources on my system. But to deploy a Postgres database, I can say, hey, I want an instance. Here's my instance. I want to deploy. I want 5 gigabytes of data. If I want to make it high availability, all I have to do is add replicas to, and suddenly I have 2 Postgres instances. The HA system uses a distributed consensus-based setup, essentially the Raft algorithm, so that way there's no single point of failure in it. Down below, you can see that I've deployed a backup repository, so I get backups by default. Things are continuously being backed up in archive, so that way if you need to perform a disaster recovery operation like a point-in-time recovery, you don't need to sweat and wonder, like, are my backups there? or backups are there. You can recover easily from that. If you want to explore the CRD, kubectl explain will give you everything you need to know about that. And we can dive into it and see everything that's available for deploying a Postgres cluster. Just dive into the instances a bit more. If I want to add more resources or set limits, I can go to the resources. I can use some advanced Kubernetes deployment strategies or tolerations. The upcoming release, you can use pod topology spread constraints and other things that have come out in newer versions of Kubernetes and OpenShift. That being said, I think I've probably stalled enough for time pitching all the benefits of deploying Postgres with an operator. We can see that our Kafka broker is up, all of our databases are up, and everything is looking good. So let's start populating some data in our edge databases. I'm gonna go back to our demo script. Actually, before we start doing that, I actually need to grab 2 secret values, which are gonna be used later on. It'd actually be cool to explore the secret a little bit because the way the secrets are designed with the Postgres operator, it's actually relatively convenient to tie it into an application. Of course, I'm doing it, the old-fashioned way by extracting the value out. But in an application, it actually, if you're following the 12-factor pattern, it's actually fairly simple to tie in. So let me just show you that real quick. Describe secrets, edge. There we go. So essentially all the values you need to connect to a Postgres database are encoded in the secret. So you can tie them into, say, environmental variables directly from the secret. So that way you don't actually need to share the secret value if you don't want to. In this case, I'm doing it just for conveniences of this demo. But that's one of the advantages of secure design within Pigo. All right, so that's it. I've transferred those values around. Actually, I need to put one in one more place. Benefits of a live demo. All right, so now that's done. Let's start adding some data into our database. I'm going to do this. So actually, while I'm doing that, first I'm going to deploy our Kafka connector, which is going to bring up Debezium, and we'll talk a little bit more about that in a second. And while that's coming up, let's populate our edge databases with some tables and data. So I'm going to do the shortcut way and execute directly into the databases. I'm going to create a table called users, my first edge database. And I'm going to insert a user. That's simply myself. We're done. We can see that in the edge 01 table, we have a bunch of users. Cool. Now I'm going to exec into the other edge database. And we're going to create the same exact table and structure. And we're going to add a different user this time. We're going to add Jehlum. Cool. So we can see in the second edge database, Jehlum is a user within it. Now we're going to exec into the analytics database and set up something a little bit different. Basically, we're going to prepare for doing some real-time analysis on this data. So I'm also going to create a users table, adding a field so we can record the timestamp when it was created at. Then I'm going to create something to do some analysis. Here, let me copy and paste it. So I created an analysis table called user signups per hour. So we can see how many users are signing up per hour. If all goes well, we're only going to see 2. And I have a trigger basically to detect that every time every time something's inserted into the user's table, we recalculate this. Now, there's many different ways we can get at this. I could actually have this Debezium stream directly into an application and perform this calculation, or I can have a materialized view on the table. Just for the purposes of this exercise, I built out a trigger. Cool. So we should be just about ready with our Kafka connector. We'll talk a little bit about that for a second. So the Kafka connector, that's part of the Strimsy operator, and basically allows me to deploy a connector, in this case Debezium, to be able to transfer data between my databases. Just for a sanity check, I'm gonna create a log on it. I'm gonna tail it in case anything goes wrong during the demo and we need to do some live debugging. And also, I'm going to, I basically have it referenced as one of my exec commands, and I'm going to sub out the pod name. Cool. So we're about ready to go. Let's get edgy. There's two parts to connecting our databases up. We need to create sources and sinks. Sources are essentially the data sources. It's basically saying like, hey, here are my edge databases, extract this data out and put it into a Kafka queue. And sinks are saying like, hey, there's data in a Kafka queue, read in this topic and plug it in. I will note that I might need to run this a couple of times based upon some of the persistence settings I have set up in my local environment. In a production environment, you would not need to do that. So I'm going to create two sources. Ooh. First, I'm going to get my mouse under control. And then I'm going to create two sources that's going to pull data in from my Edge 01 and my Edge 02 database. Cool. So we have created both of these. And then I'm going to run my sync. Actually, before I run my sync, I realized I need to grab the password of the new database I created, which I did not do before. It's a JDBC password, so I need to grab that. And let's set up our sync. So what the sync is going to do is it's going to pull data out of the queues and put it into, our analysis database. So let's see what happened. It looks like I might have had an error somewhere. That's why we do this. This is on the sync. Okay, let's see what happened. I probably copied the password incorrectly. So we'll try that again. It's not a live demo unless something goes wrong. All right, let's try that again. Okay, looks like we were able to connect this time. So let's see if we actually got the data in. If not, I'm going to run those commands again and it should work. All right, we're in our Edge database. Did we get the users in? Nope. Okay, so here's what we're going to do. I totally agree with those sentiments. All right. Nope. So I still have an error somewhere. Okay. I do want to get to the really cool part of this. So all right, we're still having a connection error. All right, so if you bear with me, we will. Of course, this. Of course, it works well in rehearsal and it doesn't work live. We'll try one more time, and then we'll go for questions. Because it is really cool when it does work, which it did, of course, right before. Yeah, so that all looks correct. Right. That could be the issue right there. Yep. Okay. So I'm somehow failing, the password authentication step. I'm gonna try one more time, and if not, then I've been defeated by the live demo gods. Just want to check one thing as well. Cool. Okay. All right. So we are up and running. Yay, we did it. How about some live troubleshooting? So cool. So we have our user data from our edge sites here. And if we look at our user signups per hour, here we go, it got updated. So let's try to complete the demo successfully. I'm going to insert one more row into one of the edge databases. So again, I'm gonna just go quickly do it by execing in, which may have, if I wasn't execing in, I may have discovered my incorrect password sooner. All right. So in this table, we have these users. Let's insert a new user, and I'll say can't get password correct to make fun of myself. Cool. So we have a new user. I'm gonna make sure my stream is set up correctly again, because as I said, I've had some weird persistence issues on my local environment. All right, so that is set up. Let's make sure our sync is set up again. And again, in a production environment, you would not need to do this. In a production environment, you'll also get your password correct too. All right. Let's see, did the user get inserted? Yes, it did in our analysis database. And did our table get updated with the stats? Yes, cool. So we just did some real-time analysis on the edge with a few bumps along the way, but we are living a little bit on the edge. But that's that edge. This is an edge computing environment, and you can see that I can do work on other Postgres databases that are somewhere out in the cloud, and then bring it back into a centralized environment, to perform later analysis. This is cool because all these different databases are in write mode. These are not necessarily the replicas. I can attach replicas to each of these databases for high availability purposes, but I can still do this distributed real-time analytical computing in a way that can conveniently shift the workload all throughout your environment. So with that, I will conclude this demo and pass the screen back to Jehlum.
Awesome. Thank you, Jonathan. That was a great demo. We were able to showcase how to get data from edge to the central database, which is a success.
And I was able to recover in real time. Disaster recovery.
Yeah. Yeah. So just to wrap up and just to summarize, So, edge computing really adds flexibility to organizations, and it gives the capability to use a lot of good data driven insights, and you can place applications where it makes sense to the business. Databases at the edge really help turn these insights into action faster. As we just saw, you can place a database at the edge and you can send that data real time into a central database and just work really quickly, so you can achieve business goals. And Red Hat OpenShift and Crunchy Postgres SQL together, with both of these together, you can scale and simply manage your databases across hundreds of sites and derive a lot of valuable insights from your data. The Crunchy Postgres operator really helps automate a lot of things, and it just provides an excellent user experience. And our partnership, and you can really benefit from the partnership that Red Hat and Crunchy Data have. So with that, we conclude our presentation. I've added some links. Please go there to learn more. There are ebooks, there are videos. From our end, I know there are some from Crunchy's end as well. So please learn more and please reach out if you are interested. Thank you.
Thank you.
Okay, thank you very much for that. We did have one question here. Is there a link to an example project?
So there is actually a blog on the Red Hat blog where I talk about how you can get this set up. I forget when it was published, but I can get the link for it and put it in the public chat. We can also it also gave me a great idea for setting up an example project for getting this all up and running.
Mm-hmm. Excellent. And just a reminder to the attendees that if you do have a question, you can head over to the Q&A tab and type your question there. And for now, we can just give it a quick second or two. Okay, and the link was posted, so thank you again for the link. And just as a of course. But just as a reminder, today's webinar has been recorded, so if you missed any or all of the programs, you'll be able to watch it again. We will be sending an email with a link to access the webinar on demand, and it will also be available on devops.com. So look in the on-demand section in the webinars, and it should be there. And I'll go ahead and announce the 4 Amazon gift card winners for today. Our first winner is Mario Z. Congratulations, Mario. Our second winner today is Yuri M. Our third winner is Nestor F. And our last winner is Clifford W. So congratulations to all our winners. We will be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, please check your spam folder. And so with that, big thanks to Jonathan and Jehlum for an excellent webinar. And thank you to the audience for joining. This is Julio Godinez signing off until next time. Be well.
Thank you, Julio. Thank you, Jehlum. Take care.